In this video, let us talk about Liskov Substitution Principle, which is the third principle of the solid principle. And it states that a subtypes must be substitutable for this base classes. So sub and base here refers to the parent and child relationship. Let's say if there is a parent P and a child C, then the object of the subclass, which is child, should be replaceable with the object of the parent, which means parent P equal to new parent, right? In that new parent, you should be able to fill it with a new child or any extension of the children, right? So that is what basically the Liskov substitution principle states. It's not only declaration of that, parent P is equal to child, but we should also make sure that while substituting that, we should be able to see that it is not breaking any of its parents behavior. You should extend a behavior, that's fine, but we should not be able to break a behavior. So basically, thanks to the IDEs and all, if you try to write it out, then as a line, I'll go to the example. Yeah. So let us look into the non-compliant one and the first, and then go for the compliant solution. So here there is a class named bird, which has method to fly, and it is something written out here, bird is flying, something like that. Okay. So now I have a requirement that is an ostrich, which should incorporate, or it should have the capabilities of the bird. So that's why I am trying to, by just looking into it, I'm just trying to extend ostrich with a bird. So now ostrich is an extension of bird, which means that, I mean, by definition, in the non-compliant solution, we have defined the bird in such a way that it flies, all birds flies. But when we come to an ostrich, we have realized that ostrich does not fly, right? So here comes the situation where you are not able to substitute an ostrich for a bird. Let's say there is a program which accepts a bird as an argument or bird as an input. And if you try to pass ostrich in that place, then ostrich does not provide the capability for a fly method. Here I have written something, just to avoid the compile time exception. But in the real life, if you think about the real ostrich and real bird, real other parrot or something like that, an ostrich cannot be a good fit for a bird. I mean, all kinds of birds. So we have to classify it. We have to classify it as a flying bird and non-flying bird, or a generic bird or a flying bird, something like that. So here, if this is the approach, we are failing. We are violating the Liskov substitution, because an ostrich cannot be substitutable for bird because it does not have the fly method, or it does not have the fly capability. Let us see how this can be fixed by following the Liskov substitution principle. So if you look into it, the compliant one, I'll close these classes. Most of the class names are same here in the two packages. So let us go to the bird one. So I have added all the classes here in the same file, but they refer to different classes. Here is an interface bird, which has a method to eat, and another interface which extends bird, and it adds another capability, which is fly, and this is named as flying bird. So by looking at these names and these interfaces, you must be identifying how this solves the problem that we faced in the non-compliant one. So the class parrot is implementing a flying bird which can eat and which can fly. And the ostrich, it only implements the bird, and it can only simply eat, it cannot fly. So thereby, we will be able to substitute an ostrich for a bird, and a parrot for a bird, and parrot for a flying bird, right? So there is no breakage. There is no breakage while we try to substitute the subclass for a superclass or a base class. You can substitute ostrich for a bird. You can substitute parrot for a bird. You can substitute parrot for a flying bird also. Since ostrich is not implementing flying bird, it is implementing directly bird. So you can substitute it for a bird. So this is how you avoid violating this one. So by segregating interfaces, or by creating interfaces, by achieving abstraction. So if you look into most of the examples, they use interface, they use abstraction to achieve the particular principle. So I hope you have understood what we are trying to achieve here. I have a test class which really identify what it is. So now I am able to substitute ostrich for a bird, I am able to substitute parrot for a bird, I'll be able to substitute uh, just bird equal to new parrot, right? This can also be achievable. I mean, line number 8 can also be achievable because parrot has all the things that bird has, and additionally, it has another fly method, right? So in every case, we are not breaking the substitution principle. So this is how it helps, running into this kind of scenarios, ostrich kind of scenarios where you had to, you know, so here there is a statement. Why is this bad? Ostrich is a bird, but it breaks the behavior expected from the bird, which is flying. So code using bird may break when ostrich is passed, right? I mean, as we already discussed, so this is what it is. So in a, if you do not follow it, all you have to do is like, you have to do some, some sort of implementation with mock behaviors, which is not really good. So that's why it is best to habituate or incorporate Liskov's principle at the earliest stage of the software development. Yeah, that's all is all about Liskov substitution, and let us talk about interface segregation in the upcoming video. Yeah, thanks for watching.